Hey guys, today I'm going to be telling you about some black hole facts that you never knew were true. So let's first discuss what a black hole actually is. A black hole is where the time dilation and gravity are so strong that no light emitted from the surface can escape into regular space. Now, since light can't slow down, it can't actually fall into a black hole unless it's pointing towards part of the black hole. And light can escape the area around a black hole because otherwise we couldn't image them. Now let's talk about how black holes actually form and their types. So a stellar mass black hole forms when either two neutron stars collide or a star of more than 20 solar masses undergoes a hypernova. And I suppose on the lower end it might be considered a supernova. So, very high mass stars will fuse hydrogen into helium, and then the weight will crush down, allowing them to fuse helium into carbon, oxygen, and neon, and magnesium, and just keep going, fusing more and more alpha particles until you get silicon, sulfur, and eventually iron, which requires a few beta plus decays, but it does eventually get to iron. And this is where it gets interesting, because iron and nickel have the most binding energy per nucleon, meaning that they take the most energy per nucleon to split them apart. This means that they are pretty stable, because binding energy and stability often go hand in hand. And by calculating the mass defect, iron cannot fuse with silicon or itself exothermically. It can fuse with lighter isotopes exothermically, but there aren't that many of those present in the core because they have already been burnt. This will cause the star to, once it loses its energy, keeping it from collapsing, collapse. And for stars of 8 to 20 solar masses, this ends up with a neutron star, which is funny because electron capture is actually an endothermic process. So that means protons and electrons actually repel at short distances. But all of that lost potential energy of the material being held up by the internal pressure of the star is converted into kinetic energy, and then through friction is converted into thermal energy, which will allow for electron capture to occur. Stars of more than 20 solar masses just won't stop collapsing, and the amount of potential energy lost will even be able to overcome the repulsion between quarks, causing everything to just collapse in on itself. And that's how you get a black hole. Now, at the surface of a black hole, time dilation reaches infinity, meaning that black holes can never truly form. They can only almost form, which means that every black hole is actually just a really, really dense quark star. Like, really dense. This also means that for a 100% event horizon to form, it would take not only infinite time, but also nothing would be able to enter it. And this is also true for almost event horizons, because it takes so much time that anything entering would actually evaporate from gravitational radiation and Hawking radiation before it actually entered, or even merged with it. Now, if you try to calculate the time dilation inside of a black hole, you can't, because space and time don't work inside of a black hole. I mean, true black holes don't technically exist, but let's say theoretically you had a true black hole. Inside of a true black hole, time and space do not work. Because if you try and plug in the formula, you get an imaginary number, which 99% of the time in physics, if you get an imaginary number when you aren't specifically supposed to, physics is basically saying you can't go here. That's all it's saying. Now, if black holes don't exist, then how come there's no light emitted from a, quote, black hole? Like I said, black holes almost exist, and the time dilation reaches almost infinity. So what I'm saying is that any energy that is emitted from the black hole will be stretched out over infinite time, or almost infinite time, because power is energy over time, and if time becomes almost infinity, power becomes almost zero. Now, if black holes can only almost exist, then how come light can't go through them? Well, the reason is because any light that goes in would be immediately converted to kinetic, thermal, or gravitational energy as it goes in, and would be stuck there almost. Now, if black holes can never truly exist, then how come Hawking radiation is emitted from the surface? Well, the reason is because of gravitational radiation. As the particles near the almost black hole interact, however slowly, they will interact, producing gravitational radiation. And that gravitational radiation is one way of interpreting Hawking radiation. Now, there's an argument called the naked singularity hypothesis, which is that if you overload a black hole with properties like spin, charge, or any others that repel each other, you will remove the event horizon. Now, technically, you could. It would take infinite time, and it would evaporate from Hawking radiation before that happened. But you could, but not in the way you expect. By removing the event horizon, what would actually happen is all of the stuff piled up on the surface because of time dilation would eventually be flung outward, although the black hole would evaporate from Hawking radiation before this happened. Now, if you somehow manage to do that in an amount of time that isn't impossibly long, nothing would happen. Either the black hole would explode and just release a buttload of energy without breaking the universe, or literally nothing would happen. Because space and time do not exist inside of a black hole, and removing the event horizon won't remove the mass. It will essentially, what it will do is that the time dilation will keep the event horizon there, even if you overload the black hole with properties. Because overloading it with quantum properties will not remove the mass, which is what causes the time dilation. It's called gravitational time dilation to distinguish it from Lorentz transforms.